Alright, so I'm going to be talking about the cardiac cycle. The cardiac cycle talks about the pressure-volume relationship or loop, and it refers to the pumping capacity of the heart, where pressure and volume changes are observed as the heart contracts and relaxes. And so, like any other graph, we always want to look at the y-axis in the left and the x-axis. In the y-axis, we have the pressure of the left ventricle, and in the x-axis, we have the volume of the left ventricle. And so we're going to start with the letter A, and that's when the diastolic feeling starts. When does the diastolic feeling start? Well, it starts when the mitral valve opens, and it will terminate at point C, where the mitral valve will be closing. Okay, simple as that. So I'm going to be discussing this in a little bit further about the diastolic event. And so the initial decrease in the left ventricular pressure, that is from A to B, the initial decrease in ventricular pressure is due to the progressive ventricular relaxation and distensibility. Distensibility refers to the capability of the heart to stretch. From B to C, we see a progressive increase, and that is due to the ventricular pressure increase that reflects the ventricular feeling and changes in the passive elastic characteristics of the left ventricle. And again, this small pressure change, it will reflects the compliance. Compliance just means the ability to expand. Compliance and distensibility go together, and yeah, that's that part. And so this small pressure change of right before C, so right here, is due to the atrial kick. Atrial kick just refers to the contribution of the atrial contraction to ventricle feeling. Okay, so that was from A to B and from B to C. Now we'll go towards the C to D, and C to D has a special name. It's called the isometric contraction. Why? Because this is the point where we talked about the mitral valve closing. Okay, the mitral valve is closed, and the left ventricle will build up its pressure. And so once the buildup of the pressure of the left ventricle occurs, there will be a change in pressure, obviously, but that will be happening without a change in volume. Now, how would you do that? Well, in order to do that, you gotta have both valves closed. Okay? And so the mitral valve is closed due to the ventricle pressure exceeding the left atrium pressure, but the aortic valve is still closed. And so in order to open, the left ventricle needs to exceed the aortic valve, and that would occur at point D. And so just to recap, during isometric contraction, that is from C to D, the buildup of the ventricular pressure occurs without change in volume. And that's simply because the mitral and aortic valve are both closed. So imagine the heart starts to contract, but it still hasn't exceeded the pressure of the aortic valve. Therefore, still no change in volume. In other words, the blood will not go anywhere. So during the so we're at point D, where we talked about that and said that the aortic valve will open once the ventricular pressure exceeds the aortic valve. So once the ventricular pressure on the left side of the heart exceeds the aortic valve, the aortic pressure, the aortic valve will open. Okay, so from D to E, that represents the ventricles. So the ventricles contracting. That's all it represents. I mean, it represents the so it keeps contracting. Sorry, from C to D. We talked about that's the initial step of contractility of the left ventricle, and so it will just keep contracting. Okay, so it will go towards maximal pressure, and that causes by the rapid ejection phase. The rapid ejection phase is just from D to E, where the volume is reduced. As you can see, from D to E, you're going towards the left. Volume decreases, and so as the volume decreases, the ventricle pressure increases, and that increase is due to the contraction, nothing else. Okay, so point E, we'll talk a little bit further in the next slide, but that just represents the end systolic. Sorry, that represents the systolic pressure, the maximal pressure that the left ventricle goes to. And so from E to F, there's a slow ejection as the pressure drops. All right, so the left ventricle drops, the pressure of the left ventricle drops, and it goes towards F. And so what happens at F? Well, the aortic valve will close because the ventricle relaxes in diastole, and the pressure drops below the aortic pressure. And so when you drop below the pressure, you're going to have the aortic valve closing. And that's when the isovolumetric relaxation starts. And so this is the same as the contraction part, except now we're having both again. The mitral valve that closed over here at point C, still closed. The aortic valve open. Now the aortic valve closes. So now we're looking at both valves closed. Therefore, no change in volume. That represents this line where you see 50 from F to A. Okay, so just to recap, from F to A, there's isovolumic relaxation where volume does not change because the aortic and mitral valve are closed and pressure drops due to the relaxation of the heart. Okay, so after contraction, it's got to relax. So then we go back to A, where we see that the mitral valve opens as the ventricular pressure drops below the atrial pressure, and that completes one cardiac cycle.